Hello and welcome to the Cyber1 YouTube channel. In this video we're going to look at part 2 of Fred's brain, in this case the program, and continue where we left off in the last video. So in Fred's program we went through the breakdown of how we've split the program up to make it easier to work with and to find things in it. And we started going through listing all of the controllers and the system and the configuration files. The next thing we need to look at is the head. Within the head we have a lot of servos, and servos are a complex service to work with. So we're going to go through the program. One of the first things we do is we load the configuration file, as we've done with most of the others, and that just makes it easier to separate the configuration out from the program itself for people wanting to use this program on their InMoovs, which may not necessarily be configured the same way as mine is. So in our configuration file, I've got a few notes in there as to what we need to be aware of. The valid names of controllers, for example, such as the Arduino left, Arduino right, for those of you with a standard build, Arduino Nano I use for some stuff, but head, back, right arm and left arm are ones I'm using specifically for Fred 4 servos. For each section or each servo that we're dealing with, we will have whether or not it's enabled. So I'm making allowances for some builds that don't have as many servos as I have, or for some who have more. So we enable, in this case, the jaw servo. I'm attaching it to the head. In the default InMoov project, it would be attached to the left Arduino. In my case, I'm connecting it to pin 9 on the headboard. For a default build, it's pin 26 on the Arduino. Now this is where things get really different because it can vary dramatically from build to build. I've set minimum position of 70 and the maximum position of 140. Now this is degrees of rotation of the servo itself, not the jaw itself. Because of the way they're hinged and piston driven, they don't actually line up to degrees of movement of the jaw. In the standard InMoov build, when Gael put his together, he ended up with a minimum, so a closed position of 10 and fully open at 25. Now there's also a possibility of setting a speed control. I'll go into that a bit more later, but I've got speed control turned off, so a jaw velocity of -1. And we basically just repeat all of the information required for each servo. Now, one of the things I would like to note is the way the program's set up, it will interpret a minimum position with a greater number than a max position as an inverted servo. That is, when you send a value of 0 or 10 to the servo, it's going to put it at the opposite end of the range. So in this case, to a rotation of 180. That way I can actually have the X, or the left and the right eye, which have opposite servo orientations, to be driven with the same value. And in my case, I've added in provision for separate eyelids within the head of the robot for upper and lower eyelids. I don't have a left and a right eyelid as such. I've only got an upper and a lower. So in this case, I've got 2 servos disabled, but I've made allowances for it in the code, and all the code will look for this. So going back to the servo head, we can see here that first thing we need to do, if it's enabled, we need to create and start the servo service. We're going to call it jaw. Make sure that this name here is the same as this name here when you're using the Servo Service. It creates all sorts of trouble later on if they don't match. In here is the name of our service that we're creating, and this applies to any service that you're using. So you create and start your service, make sure that the object name and the text name are the same, and then the name of the service you're starting, in this case Servo. Once we've started the Servo service, we need to attach it. So we attach it to a controller. Now the controller could be an Arduino, one of the output pins, or it could be a PCA 9685 servo driver. In this case, because I don't know which one we're going to be using, I've actually put in provision to catch all of the different types and do the assignment correctly. The top one, the first one, is actually the one I'm using, which is the head. Alright, so the next thing we need to do is set the minimum and maximum. Now, in earlier versions of Manticore, we used to set the min and the max and control it that way. But in later versions, starting with Manticore, the map function was introduced. And that map function can be very good for abstracting things out. So for an example, with the jaw, we can have 0 to 100, where 0 is closed and 100 is fully open, regardless of what the mapping points are. When we give it a value of 50, the jaw is half open. There's advantages to doing it this way with the mapping, and that is now I can configure the rest positions for each of the servos, and it will consistently work across whatever range your servo might end up being. So when you mount your servo to operate the jaw in, it might use half the range, or its range will be slightly offset to someone else's range. Or if your jaw arrangement is set up where the servo is upside down, it might be reversed compared to what I'm running. So the ability to configure that way and use mapping to give us a consistent output. Okay, so that covers mapping. When we detect that the the minimum position is a greater value than the maximum position, we actually swap our mapping around, and then later in the code we will actually invert the servo. So everything still works the way you would expect it to work. And now with the rest position, I can set it at 10. So the jaw's not firmly closed, but it is mostly closed. And that seems to work quite well. Now, with the introduction of Nixie, which is still in development, there was a change from using set velocity to set speed. Now, a lot of this is to do with velocity being a vector, and you set the direction as well as, a vector is the direction as well as the speed at which it's traveling, whereas set speed is just speed. Set speed is not available in the Manticore versions and earlier, so as of the start of Nixie, they started using set speed, and they've what's called depreciated set velocity. So in Nixie, set velocity does still work, but it's advised not to use it. Jaw set auto disable true. When you're not actually driving a servo to a position, it's a good idea to let it turn off. One, it saves power, which is very handy if you're running on batteries. And two, if you've got your configuration not quite right, you can be putting excessive strain on the servo's motor trying to hold it in a position that it can't get to. And that can cause servos to burn out. In fact, it has done in the past, and one of the reasons is set auto disable was introduced back in Manticore. and then we issue the command jaw rest, which sends the jaw to that mostly closed position. With the following statements, I actually included the invert with the mapping just to simplify the code a little bit, and then it's pretty much the same for each of the different servos that we run throughout the system. Okay, so once we get through all of our servo definitions for the head, we've also got the neck. Again, the neck calls on the configuration file first, loads the configurations in. There's only 3 servos allocated for the neck, and you can see them listed here. In the original version that was released many years ago now of the InMoov neck, it could only pitch up and down, and then you had the servo inside the head itself to do the yaw or turn left and right. So we've got the yaw one is allocated there. We've got the head pitch up and down. Later versions have also included a roll neck, and this is a pair of servos configured as a master-slave setup using a single output to control the rolling of the head from side to side. And as with all the other configurations where possible, I've tried to include what the standard configuration is from the InMoov site. So if you choose to use this instead of the original InMoov program, you're quite happy to do so, and you can use those as a guide. Once we've loaded the configuration, we're doing the same thing. We're just loading the servos up. So we're creating a servo service for every single individual motor or servo used in the robot. And they all work very much the same. We've got the torso. Again, first thing we do is we load in the configuration file. Again, the configuration file is set up to support multiple types. So in this one, you can see I've got the roll top stomach, which is the roll of the body itself, left and right. I've got that attached. I have not yet done the rotator for the body, so I've got it disabled. And some builders have also included a second servo set to actually pitch the body backwards and forwards. Knowing that that's a possibility, I've allowed for it in the code, but I've got it turned off because I haven't got it installed. I haven't installed the arms yet, so the next few are not yet ready to go. So that'll do for this video. In the next video, I will explore some of the IOs. IOs are interesting, things like ultrasonics, passive infrared detectors, neopixels. And I am still working on some of the neopixel coding, so in the next video we'll look into all of that. If you like these videos, don't forget to click on the like button, subscribe if you haven't already done so, ring that notification bell to be notified when I release new videos. There's a Discord channel that you can go into, ask questions and provide some feedback so that we can improve these videos for you down the track. I'd like to thank my #1 Patreon, Go Lucky. Patreon helps get equipment in to actually build these robots and show you how they work. There's a link in the description for Patreon if you also wish to help support the channel. Patreons are getting videos. Currently they're running 2 weeks ahead of everyone else, so they can see what's coming and also make comment before it's released to the rest of YouTube. So that'll do for this video, and we'll see you in the next one.